So, how do you determine then, like you mentioned, a camera, right? So you said Halo. I know that's one one version, or a camera. So, and you got like the full Minerva. Like, how do you determine which one is which? And when you look at it virtually, does it understand the difference between those and their capabilities?
Yes. So the way we'll do that is based on discussion with the customer. So some are dealing with sites that are very high concentration of methane, like a dry gas production facility. Typically, production facilities have high concentrations of methane. A midstream facility or refining where we need to cover a larger range of hydrocarbons and they might not be dealing with methane as much. That's where we would recommend using a cooled camera. And to answer your second question, yes, our distances and abilities of those different camera types, the cooled versus the uncooled, Minerva versus Halo, accounting for the different processing power between the two, which enables us to do more detection models between the Minerva and the Halo. And then secondly, the cooled versus the uncooled, we can adjust distances of detection with Luminary software. Yep. So I'm going to go ahead and assume that this is a site production facility producing dry gas. We're keeping our tower close to the tanks where the cut percentage of methane is a little bit lower than it would be near the other equipment groups. And we're going to mock up a Halo for this site. So I'm going to give it a label, input the model, input which side of the tower we're going to place it on, and I'm going to put it at the maximum height of the tower. And I'll add the camera. Let me flip it around so it's facing more the center of the facility. And now this gives us a really cool opportunity to investigate. One thing that's really important about this, our placement of cameras, is the distances from our device to different equipment groups. So you can see here in the top left of the image, and I'm going to maximize it so you can see full screen. This gives us the ability to look at what the representative field of view of the camera would be before even placing it out at the site. I can switch here to this distance mode, map it out to that separator at the end there, or the row, and we can see we're within our 100 meter recommended detection limit distance. So this would be a pretty solid placement here.
Nice.
Yep. The next process we'll go through is something called adding zones to the detection. Because the way our gas camera works is it's going to look at each equipment group or a zone in a field of view for increments of 2 minutes. Once it's done looking at the wellheads for a period of 2 minutes, it's then going to pan and tilt to the separators for a period of 2 minutes and keep rotating until it does a full 360 tour, which may take 10 to 20 minutes, depending on how many zones we add at an operator's facility. Easily enough, you can do so from these images here. So that looks like a good zone setup. I can save it here. And now this is representative of zone 1, where the camera will pan and start its tours. It's going to stare at these separators and this VRU compressor for a period of 2 minutes, look for any detections, and then move on towards other equipment groups. So this process of digitally twinning the operator's facility gives us a really no-risk way to start mapping out where these cameras should be placed, how many cameras should be placed, and then work with you, the operator, to figure out where is it feasible to be placed. Does our best option work for you?